1.5% at my previous company. Today, in our current discovery, using this info AI-driven, gene-driven discovery, we're at 30%. So that means 30% of all the microbes we found from nature have activity against weeds. Amazing, amazing.
Hey everyone, welcome back to the Particle Accelerator podcast, where we talk to future thinking business leaders about how to accelerate their business and grow their team. I am here today with Pam. Pam, would you please introduce yourself?
I'm Pam Marrone, and I'm co-founder and executive chair of the Invasive Species Corporation.
Invasive Species Corporation. Tell us a little bit more about what they do.
So we look for naturally occurring microorganisms like bacteria and fungus that produce natural compounds, just like penicillins from mold, to control invasive species in water, forestry, and agriculture. Invasive species are a $500 million problem every year, causing havoc around the globe. These are animals and plants that are in the wrong place, and microorganisms that are in the wrong place, that come from their native lands to invade in new lands and wreak havoc. So we're looking to control them using biological solutions.
That's super fascinating. Oh, cool. Well, I would love to get into that, but first I'd like to get to know you a little bit better. And I do that by asking, what was your first job? So for me, I had a paper route when I was young. What was the first way that you made $1?
Babysitting.
Babysitting. Love it.
Babysitting my neighbors. Yeah.
So you must have been a very responsible young person.
I was, yes.
Awesome.
Very.
Well, what toy or hobby did you have as a child that inspired what you do career-wise today?
Collecting bugs, being out in nature and gardening with my mom. Yeah.
That's awesome. Did you do the mothballing where you do the, what do they call that? But where you have a little case and they do the pinning?
I did that.
Yeah.
But I actually preferred having them live. So I kept it. We had built a pond out of the swamp when I was about 7. And then I learned all about the different water bugs that lived there. And I collected them and kept them in an aquarium in my room and freaked out my sister all the time.
I know. Very cool. Very cool. I think I left I was very interested in this chicken heart that we had found. I left it in a jar in my room for far too long. But very cool. Well, what was your favorite and least favorite course in school?
Least favorite was chemistry. Little did I know that my whole career would be around natural product chemistry. And my most favorite, of course, was always biology.
Awesome. And what quote from a famous person lives in your mind rent-free?
Lives in my mind rent-free. There's an ancient, I believe it's very ancient, like Greek or Roman, and it's out of the earth, everything we need, nature will provide.
Very cool. There for a moment, I thought you were going to say there was this very ancient slogan, just do it. And I was going to have a bit of a chuckle.
Well, that's a good one, too. I've used that in various businesses that I've drawn a little swoosh and said, just do it, please.
Just do it. So fun. What do you feel was the greatest invention or discovery in the past 300 years?
Oh, wow. That's a really interesting one. Good question. There's so many that could be. In 300 years. I don't know. There's too many. I can't answer that one.
Okay. All right.
What would you say?
Well, so I ask this question a lot, and I frequently get electricity, the microchip.
Yeah.
But for a biologist, there has to be something unique that's just really changed the world of biology that I wouldn't even be able to think of.
Yeah. Thank you for that, because yes, discovering the nature of DNA, of course.
Mm-hmm. Yeah,
Being able to code DNA. Absolutely. Yeah.
that's awesome. I was talking to an inventor the other day, and they feel that they have a mechanism for figuring out what molecules are actually going through the human body in the blood in real time. So they take a larger blood sample and they can get a better sense instead of just the smaller sample where, by the time you get it under a microscope, it's totally changed.
Yeah.
And so I thought that was really interesting that they were
That is
looking
very
at kind
interesting.
of molecules in real time.
That is very
Cool.
interesting.
Well, what tech trend has significantly impacted you or your industry, and how did your company respond?
This sounds really trite because quaint or whatever or stereotypical because um, you might think everyone's gonna say AI. But there's two things in ours, but AI is one of them. But before I get to AI, I will say being able to sequence the genes of an organism, and in our case, a microorganism. So we're able to do the full gene sequence of a microorganism, let's say a bacteria. So we know all the different genes and and then we can figure out what those genes do. And this helps us commercialize, tame and commercialize a microorganism to control a pest better than we've ever been able to do before by understanding um, what the microbe is made of. And so that's a huge technology. The second one, as I said, it sounds quaint because everybody talks about AI, but as I launched my fourth company, this Invasive Species Corporation, our investor and everybody said, well, you got to use AI. So we hunted around for how AI could actually accelerate what we're doing and found that it wasn't quite there yet in terms of actually helping us discover a microbe. But once we have found one, AI helps us be data driven or information driven in how we select one for testing to see if it kills a pest. So I'll give you an example. So, okay, we go out to nature and we go to the areas where the pests live and we bring our the scientists bring their petri plates, which has food for the microbes on it. And on site, we find the microbes right there and then that live there. We bring them back to the laboratory. And then the first invention, as I said, sequence the genes. We then sequence the genes of the microbes that we found, and it identifies the name of the microbe. It could be the species name. It might be unknown, or it could be just the genus instead of genus and species. So because some of these things are novel, but if it is known, then that's where the AI kicks in. So there's huge data sets out there about what a potential microbe might be doing. And is it a bad microbe? Is it a human pathogen? Or on the other hand, is it something completely benign, but is known to kill a pest? This way, our scientists can mine at a very lightning speed all the data that's out there about that particular microbe. So then they can say, oh, this one is known to kill a weed. This one is known to kill algae. This one's known to kill a bug. Okay, pest. And so then they can select that one from the collection of microbes we just found and test it. And then that gives us a much higher productivity of discovery of something that's going to be significant to control the targets that we want. So, for example, in my last company, we found 18,000 microbes from nature. We tested them against a whole range of pests. This was for agriculture. Very successful. Discovered fantastic products that are scaling, doing really well now. The company was sold after I took it public, then it was sold to a big company. But our hit rate for, let's say we're going to control a weed and we're looking for a biological that can kill weeds instead of a chemical herbicide like a Roundup. Well, let's say the hit rate, which means the number of microbes that kill a weed, was 1.5% at my previous company. Today, in our current discovery using this info AI-driven, gene-driven discovery, we're at 30%. So that means 30% of all the microbes we found from nature have activity against weeds. Amazing, amazing. So it's just really transformed how we can find things.
That's cool. So really, if I said it in a sentence, it's reducing the amount of research and testing time because you can take
Yes.
the collective data and go, hey, what are the plausible solutions? Just that step from what should I do to plausible solutions is majorly reduced. So now you have things that have a much higher chance of working, and you test
Exactly.
them and you find which one is the best. That's really
Yeah.
cool.
So going from sampling the world, a needle in a haystack, to being very data driven, info driven is, really makes it a more efficient process. So the idea would be, can we find a commercial product faster? And out of the block, the ones that we find are better, and so could already be in development and before the end of the year. Mm.
Mm, really cool. Well, this may seem like the same question, but I'm going to ask it in a different way to help us dig a little deeper. What are 3 technology innovations you are betting on to drive your business growth?
Okay, so I've already talked about being able to sequence the gene of a microorganism and understand what it's doing, and then using what's available to mine data and then drive our decisions. Um, then we go to the next step, and that is making the microbe in fermentation. So just like you're fermenting, not just like, but similar to you're fermenting wine and beer in a big vat. We do the same with our microbes. We ferment them. We make them in a big stainless steel vat, but they much faster process than wine and beer. I mean, it would be 24, 48 hours rather than days or weeks or months with wine and beer. So when we move to develop a process for growing this microbe so we can scale it up and make it into a commercial product, in that fermentation tank, a lot of stuff is going on. And in the past, you'd have to do all kinds of fermentations. So you'd have these little vessels before you scaled, little versions of them, or even flasks. And you'd have to do hundreds and hundreds of these different recipes. And you'd have to try sort of random, but more, just a whole hundreds and hundreds of different fermentations to figure out the best conditions for how the microbe will grow most efficiently. Today, again, because we can sequence the gene of the microbe and we can now know, okay, is it making a particular natural product that kills the pest? Because we can suspect it is by looking at the genes that make that natural product. And then in the fermentation, now we can use, again, AI, machine learning, to once we have a bit of data to say, okay, we fed it carbohydrate source, protein source, some vitamins and minerals, and it grew really well. Then we can kick in, and there's algorithms that'll say, okay, what would make that based on the genes of the microbe as well as those conditions, the recipe that we know works somewhat. How can then we make the most of this microbe in the most productive use with that, kicking those algorithms in? So again, the tools are now allowing us to do something that's now they call it precision fermentation, which was a bit hit or miss in the past. So what's the significance of this? Again, you have a tech product, version 1.0, 2.0, 3.0, and what are we on, version 15 now for iPhone? Well, same with our products. We launch with our version 1.0. It's a good product, but it may not be the most profitable because we didn't have time to turn it into the most productive product yet. And maybe it doesn't have all the features and benefits that we'd like. We'll add those later, just like you would for a tech product, but ours is a biological product, microbe. And so what we're hoping for this new precision fermentation technology is to be able to leapfrog version 1.0 and go from version 1.0 to 2.0 or even version 1.0 and 3.0. So have a more perfected product by the time we launch. What is the significance of that? Well, we're going to get more buyers. So if it meets the customer's needs more so earlier, then maybe our revenue curve will be steeper than a slower revenue ramp, which means incrementally improving the product over time. Yeah.
Yeah. So how can you produce it faster. If you can produce it faster, it'll be cheaper for the consumer. You're trying to figure out your unit economics for the microbe
faster. And so you can make more of the microbe so it can grow more of itself,
Mm-hmm.
or it can be more potent against the pest. And those are the kinds of things we can do more efficiently now.
Yeah, you can you can predict how to grow it, but then you can also predict the steroids that will get it to grow
exactly
at an alarming rate.
Right.
Yeah,
that's right.
Yeah, that's really cool. Well, what are some of the most significant gaps between your digital and not digital, but between uh your ambitions and realities today?
Based on technology wise.
Yeah, like you just mentioned all those advancements. What's something that's a gap? Like it could still get better.
Data sets. Okay, interesting. There's all kinds of people who can run algorithms. Okay, there's algorithms are everywhere, but if you don't have data, then data sets to mine, then the algorithms aren't useful. So what do I mean by that? So we would like to be able to have huge data sets of the gene sequences of microorganisms, and those microorganisms are tested against a pest, and we know what the genes of those microorganisms do and how it kills the pest. Okay, those data sets currently do not exist. So there are companies that have tried and failed. Why? Because they got 100, let's say 110,000 microbes, and they sequenced the entire genomes of each one of those 100,000 microbes, but they never tested it against the pest, so you don't know what those genes are doing. Just because, same in the human body, you have genes sitting there doesn't mean those genes are doing something. They could just be. There are a lot of those sequences of genes that are actually non-functional. Same with microbes. So you really have to test it against something and find out its biological activity and be able to correlate the genes and the biological activity. Those data sets do not currently exist. So we're still going out to nature, bringing back, from soil or mud or compost or leaves or whatever, and then finding the microbes that live there. So we're being as efficient as possible, but it would be great to have now those data sets where we can predict better where in nature we can find these things.
Yeah, this is so interesting. I'll draw an analogy here. So in game development, sure, you can have a game that a board game or whatever, super easy, not a lot of content. But any game of size, any game that's going to provide any kind of escape will require all this 3D modeling content. And so it sounds like in your world, those data sets are the kind of the content creation. It's where all the money goes when in game development, the same thing happens. Like creating all the content, creating the world is where all the money goes.
So the National Science Foundation has funded UC Riverside to find out what is the microbiome. This means all the microbes that live there of the citrus, most very important crop for Southern California, and for grapes. So they collected samples of grapes and citrus leaves and bark and so forth, and then they found the microbes that live there and then have now characterized. So they've gotten the data, the gene sequences of all of the microbes that they found living on or associated with the citrus plant or the grape plant. So that's the start of a data set. Now, okay, what are those microbes doing? So that's what they're doing now. And then can that data now be used to predict which microbes can then control the worst pests on citrus, for example? Both citrus and grapes have terrible invasive species that can devastate the crops. And in fact, in citrus greening, which is spread by an invasive bug, it is spreading in California, and it has devastated Florida citrus. So we want solutions to those.
Yeah, so I have some friends that are involved in a legal cannabis growing operation, and they were testing for microbes at I'm going to use the wrong metrics, but like 10,000 microns or whatever, and they weren't getting any of the output or any of the measurement. They had a consultant come in, walked in, looked at things, walked out, took off all of his clothes, went and got in a separate jumpsuit from his truck and said, "You have a huge problem. How big is your microscope?" And they're like, "Well, it's this." And like, "Oh, you need to use one 5 times that in order to actually see what's going on." And there were vendors that were essentially going from growth to growth, growing operation to growing operation, that were transmitting the microbes that were essentially ruining the crops.
Oh my gosh.
And so, yeah, they ended up having this,
But
they had to scrub it all.
yeah, that
hmm
goes, yeah.
So this is very real. And so I'm connecting with this in a great way. I would think that some of the gaps, I'm seeing this in healthcare and in other places where the gap is starting to close across continuous monitoring. And you mentioned the gene sequencing. Is that something you continuously do as the production is happening? Or, and maybe you don't need to, but I would also think that your gene sequencing is done based on samples. Are you seeing anything happening with continuous monitoring? Because in a consumer sense, we can now put a glucose monitor on our arm and know our blood sugar at all times. Um, Most of us have wearables that are collecting a whole lot of data. But I would have anticipated some gaps around sample monitoring versus continuous monitoring.
In fermentation, we have pretty good tools to continuously monitor the quality of the fermentation, actually. Yeah,
Good.
that's available now. What are some other gaps? Well, when you go out to the field with farmers, that those data sets are also being generated. What the farmer is doing and how that impacts his soil and the health of his soil and then the health of his crop. And so there are companies that are characterizing the soil in terms of the microbes that live there, the microbiome of the farmer, and they're generating huge data sets, like biomakers and trace genomics are generating huge data sets that then can correlate, okay, the health of the crop with the health of the soil. And we have wrecked our soils in all over the world and farm soils. And so healthy soils is a big deal right now. And being able to characterize what's happening based on farm practices and adjust those farm practices to create a healthier soil, which then creates a healthier plant, and then you use less pesticides, is a data gap that is being filled. We still have ways to go, but it's getting there.
Yeah, interesting. What would you say the biggest challenge is to maintaining a competitive edge in your industry?
I would say it's not on the technology or discovery side. It is, we still compete with old chemicals. And so our job has always been, it has been, as I said, this is my fourth startup, and it always has been, I've always been competing against chemicals, chemical pesticides. And this is true in the new company in water, where we're treating invasive zebra and quagga mussels, and our competitors are copper and chloramine, very old toxic things. And then we have another product we licensed from the U.S. Geological Survey for controlling invasive carp, and the competitor is rotenone, which is known to cause Parkinson's and is not a great thing. So our basically competitive thing is how do we get our product to compete with these chemicals? And that's why actually all the technology we just talked about is really important, because driving down the cost, increasing the productivity of making our product in manufacturing will help us compete with these low price commodity chemicals. And that's what we're doing. And we know we can actually with all this new technology.
Well, that's so awesome. My wife and I are big naturopaths. She uses one kind of soap in the whole house that is chemical free. She kind of dechemicalized our environment in a major way. Um, I still use deodorant with aluminum, but I'm stubborn. So
There is a really good natural version that I use that is lavender and peppermint extract.
Yeah,
It's
yeah,
really good.
that's what she uses exactly.
The tactics from a little company in Fort Bragg called Hygeia Labs. It's really good. Yeah.
Yeah,
Although
um,
they do have non-scented versions or less scented versions for guys. They do.
that's great. That's great. So we're right in the middle of that, and I think it's an absolute hero's work to be taking. I just feel like we got so irresponsible in the Industrial Revolution. I remember seeing a instruction from, I think it was my great grandmother, of like what to do if you have hives, and it was like, well, you just mix a little vinegar and borax and you spray that on it just absolute, what would be an absolute atrocity, but we're still kind of doing that in small ways, throwing chemicals at the problem.
Well, yes, the chemical revolution has been quite awesome, and but we're now finding the consequences of those. And what happens is a chemical gets introduced for a particular purpose, and then it's not until 20 or 30 years later that we find out that it might cause cancer, or it might do this or that. And so that's the problem. Um, and so this is why we're helping our products. They're natural chemicals, but they're extremely biodegradable. So, and we are very well regulated with everything we do. We have to go through a regulatory process through the Environmental Protection Agency. So we're well regulated, but our products are extremely biodegradable compared to most chemicals that are synthetically made.
Well, that's cool. You may have a kind of a unique, so as you're innovating, like how do you approach risk management when you're implementing something new?
Well, that's what's great now is that the scientist in our lab told me that by now getting the gene sequence of the microbe up front and then mining all the databases about what that microbe might be doing, they have eliminated, and they had a small percentage of human pathogens that were found from our natural collections, and they're now be able to eliminate those. So right off the bat, we're eliminating from the ones we test. So that right up in front is a great screen. And then we're required, as I said, by the EPA to do toxicology studies to prove that our product is safe. But now there's so much information that we can read about the microbe that we've discovered and find out if there's any known members of that group that have kill fish or infect fish or kill bees or what have you. So now that we're so much more data and info driven, we can select the right kind of microbes up front to de-risk ourselves down the road.
Yeah, it sounds like the more data is available, the less inherent risk, like it's just kind of proportionate.
Exactly.
Well, what advice can you share for connecting technology roadmaps or your plans with your overall business strategy? I ask this because it's a common problem that all business leaders have to solve. Like, what's my process for planning for the future? How do I connect where I want to go with what I'm doing, and how do I manage the expectations of my constituents, my investors? What's your approach to that?
We're probably pretty old school. We're using all this beautiful scientific technology and stuff, such in the R&D process, but we haven't found all that much to change what we do in terms of having detailed roadmaps and Gantt charts of timelines, detailed timelines of all the functions. We know every step of the. This is not my first rodeo, and our team has worked with me at my previous company, so we've developed many products before. So we have a very detailed roadmap of exactly where we have to hit and when in order to meet our timelines. So it's pretty old school at monitoring ourselves with weekly calls by Zoom every week. Are we on track with those detailed timelines? So, well, we have the advantage that we have done this before, so we do have every single step of the process for developing a product mapped out already.
Yeah, and in much same way, software development inherits a lot of wisdom from the agile process, and so we kind of piggyback on that. Sounds like you're doing something similar.
Yeah, we've tried a lot of tools. We've tried a lot of different technology tools that might help, and I'd have to say that we haven't found any real thing that's popped out at us yet in terms of helping that process better. But we'll keep looking. Yeah.
Yeah, because the tool doesn't replace the management, right? It
That's
might give
right.
you visibility, but asking people like, well, what's the holdup? What's the critical path?
Yeah.
Tends to still be the best methodology.
I love that. Are you on Slack? Can we communicate by Slack? And I go, done there, done that. Tried that. It hasn't made anything more efficiently. So
I check email less. Slack
well,
helps me check my email less. Yeah.
on the other hand, if I have a notification of emails scrolling through my watch, and that's pretty
That's
efficient.
right. That's right. Well, what lessons have you learned from initiatives that have failed to deliver expected value?
It's interesting. With all this, all the technology, using all the technology is nice, but when it comes down to where we've had some failures, it's always been on the people front. And the people front is when people trust other people. So they listen to the people they trust and have formed relationships with. But actually, now that I think about it, it actually does come back down to data. So what was missing in the process where we made mistakes was that a scientist would say, well, he said he did this and I trusted him. So we had a detailed process of developing the steps of a product. And there's something that's really important is meeting the customer needs. So all the things that you have to do to make sure in the customer's hands it's going to work as the customer wants it to do. So there's a whole bunch of this application technology you have to apply. And I remember the time at my early stage of my previous company, Marrone Bio, where we had a miscue where we put the product out and it broke some seals in the spray rig. The farmer was going out to spray against this invasive psyllid bug for citrus greening, and he used our product, and it grated the seals, which the seals broke down and the tractor stopped. Okay, this is very, very, very bad. So we did a root cause analysis and said, okay, well, why did this happen? And everyone said, well, we tested that. And then, well, we trusted so-and-so because he tested that. He said he did. And then as we got down the next level and said, well, what actually did you do? And then we realized tested at 10 gallons of water per acre instead of what the grower was using, which was 2 gallons of water per acre, which meant there wasn't enough water to dilute the product, and it graded on the seals. Well, after that, we said, okay, we're data-driven company, not just relationships with your teammates are great, but you got to start asking questions. Even if you trust this person, when he says, oh, I did that test, how did you do it and what did you do? Show me the data. So it does really come down to information and data at the end, doesn't it?
Yeah, that's really cool. Yeah, interesting. I think you'll appreciate this. There's a guy named I'm looking up and to the right here because I have a book on my shelf, a couple of books. And there's a guy named Sidney Dekker, and he does this great work around blame, and his book is called Just Cause. And he graduates from the aviation and medical industry, where in the medical profession, you'd have this ER nurse, and, in the heat of an emergency, she went to grab a medication. The medication ends up killing the patient. Well, come to find out, they had, the system had the medicines in the medicine cabinet alphabetized. So there was something that would kill you next to something that was supposed to help you. And what we tend to do is we tend to say, well, if the person would have just grabbed the right thing, then the incident would have happened. So then we put blame on the individual. And so the kind of the lesson that Sydney went around the IT circuit talking about was this idea of blamelessness. Even if the ER nurse comes in and says, I did it, it's my fault, I picked the wrong one, I shouldn't have, I knew better, all of those typical things that a human who wants to perform on your team would typically say, then, well, everybody's like, if we just say, oh, everybody stop thinking now, we have the root cause. But to go like, hey, there's a process here, there's a system around that did not empower this person to succeed. And so in IT, in my company, we have blameless postmortems where we talk about, okay, yeah, if there was human activities and robotic activities, how did they work together? And even if the same person made the same mistake 15 times, we wouldn't blame them and fire them. We would say, okay, well, maybe we need to eliminate that step if that step is so problematic.
That is really very, very important. I absolutely relate to what you just said, because in the case I mentioned about the broken seal of the citrus grower, we had to shore up the steps in the process where it was instead of blaming the one who didn't do the test at the right water dose rate, it was okay. Where did the process fail us? Yeah,
Mm.
exactly. And I think that's really important, and so especially something with medication. Yeah.
Yeah, for sure. So what other things do you do from a cultural perspective to drive innovation, creativity? You're obviously in a rigorous scientific environment. So what do you think are the most important things in your culture?
Well, each of the companies we've started, I've started. I've learned progressively as I've gone on with the different startups. I've had some big challenges with I would say a drifted culture in the wrong direction in my last company, uh, and which resulted in one of our employees actually committed fraud and went to jail. And so what I learned is how important managing the culture is on a regular basis. You're a CEO founder, and you're very busy raising money, overseeing operations, everything. And what you do is you have to stop and focus on, okay, as I'm growing and scaling, is everybody that we're bringing on really adding to the culture and in tune with that culture and living by those culture and values of the company? So what we've done is put down on paper. We have to do it for this the new team that we have with the current company, but very early in the founding of the companies, is put down on paper what are the values, what is the culture we want to create, and then how do we monitor that? So after our big challenge at my previous company, every quarter, um, we would have the employees write down what top 3 values were we living by really well, but which ones were we doing poorly at, and then how are we going to improve those bottom 3 so that we're really living our values. And that was really important. Creativity, innovation were part of that. But things like integrity and teamwork, diversity, and fun. And the first time we did that exercise at Marrone Bio, the worst one was having fun. And I said, well, this is a problem. And we fixed it. Yeah.
No, that's great. That's great. Cool. Well, what would you say to people who are just starting their career journey or their journey into science, or maybe even some advice you would give to somebody trying their next big discovery?
Well, it's really exciting time to be in the STEM, in science and technology, engineering, math, etc.
Yeah.
STEM, because of the tools that we have and the fact that the speed of science and technology and the change in those is happening so fast that it's just amazing to be a young person coming into a science and technology field today, because the tools you have today, I'm just in awe of what you can do compared to what we were blind back then in what we were doing. Now everything is so many things available to really aid in scientific discovery that it just changes. So what's today is going to be very different 5 years from now and 10 years from now. So that may seem ominous to people that things are changing and evolving so fast, but I find it actually amazingly exciting, especially for young people. I wish I were younger and could start again at this time. But now I'm mentoring the next generation of scientists and entrepreneurs. So that's what's exciting about it. And I would encourage any young person to consider an entrepreneurial career. And the career choices for me when I was getting out of school was work for the government or work for a big company, a chemical company. And today, now, I found out you could start companies. So now there's a whole set of startup companies, much innovation going on, and a lot of money. Although venture capital is a little bit down right now, but there is still money for startups. And so that's a really, if you want to be able to wear many hats and really do a lot of different things, and really learn, a startup is a really great place to go.
Yeah, I have to agree. In my first venture back in 2000, we were racking and stacking, like literally building our own computers to build an environment, to then put the software on, to then figure out how to scale it. And now we push a couple buttons and we have an application live, so the barrier of entry has really reduced for creativity and bright ideas. And yes, if you're tenacious and creative, you can really, and you can really do anything you put your mind to, and that barrier of entry has really reduced. I think when you're
Venture has gone down, yeah.
Yeah, and I think when you're a young person, you're like, man, all this stuff I need to know, that is probably a little bit daunting because we've just stacked layers of abstraction on top of each other. And so, yeah, to kind of catch up and understand what's under the hood is quite intimidating.
I really agree that the barrier of entry to discovery and inventing something is lower. But what I found is that because of that, it's more crowded now in our industry, particularly in the I would say biologicals, which are natural products for controlling pests and or reducing stress in crops or increasing crop growth. Is so many companies have started up that it's you get enamored with the technology and you forget that you have a customer out there you have to meet a need for. And if you're going to really create a business, you better figure out what your technology is going to do better than what's already out there. And a lot of entrepreneurs I see forget the universe of competition that's out there and even investors so enamored with the new technology, like, wait a minute, the universe there's a lot of competitors out there. What is yours going to be differentiated? How's it going to be differentiated from all those others and offer the customer a return on investment that's different from what's already out there? And that is the fundamental question. So I'm pleased to see that, National Science Foundation, other granting agencies are requiring customer discovery as part of the grant making process, like the Innovation I-Corps program of NSF, where you have to talk to 100 customers in order to get your money. And I think that's really valuable.
Yeah, that's great. That's great. Well, if people like what you've had to share today, how should they connect with you?
They can contact me at Pam. This is a really long one. Pam at invasivespeciescorporation.com. But even more simply, just go on LinkedIn and type in Pam Marrone and you'll find me.
Great. Well, it's been really nice speaking with you today. And I wish you wish you the best in your endeavors, and super excited about the work you're doing.
Thank you very much. I bet you didn't have anybody talking about invasive species and microbes for controlling them yet.
You've been the first.
But it's been great. Probably since we are the only company doing it. So, but yeah, it's been a pleasure. Great questions.
All right. Thank you.